present is 49. So let them join others. Then we will start.
Okay, sir. Okay, sir.
Can you see my share screen?
Yes, sir.
Yes, sir, it's visible.
What it is showing? One table.
Yes, sir. Table.
Okay. So now you see in this table, that is your syllabus, right? For this paper, engineering physics, right? So according to your syllabus, we have to discuss these topics. That is, first is harmonic oscillator, wave motion, introductory quantum mechanics, then interference and diffraction of light, polarization, laser, and optical fiber. Okay. So this paper is divided into two halves, right? First half we will discuss by another teacher, Dr. Sukhadev Sahu. So he will discuss harmonic oscillators, wave motion, and introductory quantum mechanics. These three units will discuss by Dr. Sahu. And remaining three units, that is interference and diffraction, polarization, and laser and fiber optics, optical fiber. These three topics we will discuss, right? From my side, we will discuss this. So based on that, this topics is covered by this book. Your best book is Physics of Vibration and Waves, Pain. Second is textbook Oscillation and Waves, Goswami. And another thing, this book will include the total content, that is engineering physics, H.K. Malik and Singh. Okay. If you see this book, engineering physics, that will complete the whole syllabus. Right? In case of Pain, it is also completed the whole syllabus, but maybe some portion maybe there is a lack. Right. So now you have to have some reference books also. So for basically vibration and waves, that is main quantum physics, that perhaps you are familiar, that is Eisenberg-Resnick, fundamental of optics. Another is White or Jenkins and White, and optics by Ghotok. That is also very familiar book. Or you can see that Jenkins and White. This is very good book for optics portion. Waves oscillation. This is good for only wave part. That is N.K. Bajaj. Wave parts means harmonic oscillator, wave motion. Up to these two topics. Laser and nonlinear optics. That is loud. That means it can include this laser, right? And partly polarization. So if you want to choose a single textbook, then you can consider third one, or you can also consider first one for a single textbook, right? And for different topics, you can also see different reference books. Now, out of this, generally we will start interference and diffraction today. So it will start with Huygens principle, Young experiment, superposition of waves, but here it is linear or superposition principle, right? Linear superposition principle, it is present in harmonic oscillator. Superposition of two perpendicular waves having same and different frequencies and phase, that superposition we will also discuss in this unit, right? Then superposition of wave, condition of sustained interference, concept of coherent sources, interference by division of wavefront, and interference by division of amplitude. Division of amplitude. And basically there are some experimental arrangement and example. Next is Michelson interferometer and some related problems, right? Then in case of diffraction, that is according to your syllabus, only the Fraunhofer diffraction is there. But what is diffraction? Classification of diffraction, then Fraunhofer diffraction, single slit, multiple slit, resolving power of grating. Multiple slits mean that can be considered as the grating. Then resolving power of grating. Next topic is your polarization. So what is polarization? Qualitative discussion of plane, circular and elliptically polarized light. Then Malus law, Booster's law, double refraction, that is birefringent properties of the material that will govern to the ordinary and extraordinary ray, optical axis, Polaroid, nickel prism. There are some instruments which can produce the Polaroid light. And retardation plate, analysis of polarization. This is up to the polarization. And next is laser and fiber optics. It will includes the transition, that is spontaneous, stimulated, and mainly two categories: spontaneous and stimulated emission of radiation, population inversion, Einstein AB coefficient and their relationship, optical resonator, pumping method, helium neon laser, fiber optic, then up to helium neon laser, then we go to optical fiber. So basically the fundamental core, cladding, total internal reflection, calculation of numerical aperture and acceptance angle, and some related application that we can include in case of fiber optics. Right.
Sir, one question.
Yes.
Sir, will this whole course be taught by you or by some more faculties?
Another faculty, right? That is harmonic oscillator, wave motion, and introductory quantum mechanics. This portion, these three topics will be taught by another teacher, right? That is Dr. Sahu. So he will start your class maybe next class or next to next class, right? So first 3 unit will discuss by another teacher. Last 3 unit, that is the optics part, we'll discuss. Is it okay?
Yes, sir.
Okay, sir.
Okay. Now, so we will consider the optics portion. This is interference, diffraction, polarization, laser, fiber optics. This basically totally is the optics, right? So we will discuss the optics basically, right? And the waves, oscillation, and quantum mechanics, that will be discussed by another teacher, right? Now we come to the wave optics. So before to start, that is interference, diffraction, polarization, laser, or fiber optics, then we need to some information about the light. What is light? So if you ask these simple questions, what is light? Then what will be your answer? Simply, we can say that light is electromagnetic radiation which causes the sensation of vision. If we want to give the answer in a single sentence, then we can say that light is electromagnetic radiation which causes the sensation of vision, right? So this is the in a single sentence we can say this is the light. But if we consider the work related to light from the beginning, how this field was developed, then we can understand then the light is so important, and it is a very tough job from the beginning to predict or to discuss or to mention what it is. So basically, if we see that in the presence of Newton, at that time, a particular theory for this light or investigation of light was established, and that can be known as the corpuscular theory of light. And that theory is also developed or mentioned by Newton. And according to him, it is made up of small discrete particles. And this discrete particle is called corpus or particle or photon. Later on, we can consider it as photon. And this particle will travel in a straight line with finite velocity, right? So according to Newton, he mentioned that light is in the form of teeny particle or very small, teeniest particle, and this particle is known as, later on we call this as photon, and which travel in a straight line with finite velocity. But in 1678, another scientist, Huygens, he introduced one new concept. That new concept is the wave theory of light. That light basically made up of waves vibrating up and down perpendicular to the direction of its travel. Suppose your light is traveling in a particular direction. For example, if you say Z direction, the particle will vibrate, yeah, in the perpendicular direction of Z, right? That is the wave theory. So it is in the form of wave, right? That is Huygens introduced this theory in 1678. But what will happen that the scientific community, which around the world, the scientific community, they believe Newton. They believe Newton, and since Newton has already introduces that it is the corpuscular theory, so that scientific community cannot accept the Huygens proposal. They cannot accept the Huygens proposal. That is the wave theory, right? But in the scientific community, there is a group, some percent in the scientific community, they can believe that it may be in the form of wave, or wave theory may be true. But the majority of the scientific community, they cannot accept this wave theory. Now later on, almost the experiment of Young around 1801 and 1802, that Young first performed the interference experiment. And according to this interference experiment, he tries to explain the observed phenomena. But during that time, he failed to explain his experimental observation based on a corpuscular theory. And it can explain satisfactorily with the help of wave theory. So Young explained his experimental observation, that is Young double slit experiment, based on the wave theory. And then this wave theory is accepted in the scientific community. But before that, it is not accepted. So now the scientific community around 1802, they accept the wave theory of light. Now another point we can remember here, that since Newton has already introduced corpuscular theory in 1675, and he also explained the reflection and refraction. Reflection and refraction of light he has already explained based on the corpuscular theory of light. Later on, Huygens also explained that reflection and refraction of light based on the wave theory. But till there is a discrepancy in the scientific community, whether it is in the form of particle or it is in the form of wave. But after Young experiment, he cannot explain his observation based on the particle nature of light, that is corpuscular theory, but it can explain with the help of wave theory. then the wave theory is established. Now, in 1865, Maxwell demonstrated the electromagnetic fields that can travel through space as waves moving with the speed of light. And he proposed that light is in the duration in the same medium that light is an unmodulation in the same medium that in the cause of electric and magnetic phenomena. So later on, that electromagnetic theory was introduced, and according to that theory, that when light will propagate in a medium or in a vacuum or in free space, then what will happen, that associated electric and magnetic field is also there. Later on, again in 1905, that is photoelectric effect, that this experimental observation can be explained on the basis of corpuscular theory of light, right? It cannot be explained with the help of wave theory. So now you see that in the meantime, there is also black body radiation. So that also can be explained with the help of corpuscular theory. So now we can observe that there are many experiments which can be explained with the help of wave theory, and there are some other experiments which can explain with the help of corpuscular theory. But there are reflection and refraction can be explained by both the theory, corpuscular theory and wave theory. So based on this experimental observation and a long study, that we can say light has dual character. Light has dual character. That is, it can behave as waves and it can behave as particle based on our experimental observation. So we can say it is the nature of dual character, that is wave particle duality. It has the characteristics of wave particle duality. Here it is also mentioned, that is reflection, refraction can be explained by both wave and particle nature of light. Interference diffraction can be explained by the wave nature of light. Interference diffraction can be explained based on wave nature of light, and photoelectric effect, Compton effect can be explained with the help of particle nature of light. So this photoelectric effect or Compton effect cannot be explained by wave nature, right? It can be explained with the help of particle nature of light. So it can consider as a wave particle duality. That is, dual nature or dual character is there. Now these optics can be divided into three different groups or three region for discussion. Basically, it is actually a vast things. Optics is a vast things. That you have already learned, that is geometrical optics or ray optics, right? Before that, up to your class 12, you have learned ray optics, and there is a introductory of physical optics. That is introductory portion you have already learned physical optics, that is wave optics, that interference and diffraction, right? Interference diffraction you have already learned the introductory part, which is a topic of wave optics, but you have already learned the geometrical optics, right? So geometrical optics or ray optics, it indicates the rectilinear propagation of ray of light. It indicates the rectilinear propagation of light in a particular straight line path, right? Whereas physical optics or wave optics, it is concerned with the wave nature of light. Physical or wave optics, it is concerned with the wave nature of light. Another thing that is the quantum optics. So quantum optics, basically it will concern with the particle nature of light, and basically it is the interaction between matter and light. Quantum optics basically interaction between matter and light. So this can be considered as the quanta or particle nature. So here we can consider as light is in the form of particle, and that is the quanta of energy, right? It has finite energy, that energy packet or energy particle or quanta, right? That simply called that photon particle, right? So that can be considered as the interaction of light with matter. That is the quantum optics. So quantum optics that you will learn later on based on your study. And now we will restrict ourselves on physical optics or wave optics. Now, to start with the wave optics, first we will consider what is wave. Wave is a self-sustaining disturbance of the medium through which it propagates. Waves is a self-sustaining disturbance of the medium through which it propagates. So if you disturb a particular medium, then it will originate the wave, and that wave will propagate through the medium. For example, if you throw a stone in a still water in lake, then what will happen? There is a circular ring pattern that will originate from the point of contact of your water and the stone. Then it will move in the outward direction, right? So that can be considered as the wave. Wave is a self-sustaining disturbance of the medium through which it propagates. Now, if this disturbance persists, then this wave will in continuous. If the disturbance is removed, then what will happen? The wave will originate and it will propagate. Then after certain time interval, it will restore in the initial condition, right? But if the disturbance is present, then that can be considered as the source of continuous. Now, what is the main difference between this wave and disturbance? A wave is a periodic both in space and time. We have to remember that wave is periodic both in space and time. But a disturbance is either periodic in space or in time, or not in any one. It may be periodic either in time or it may be periodic in space. Otherwise, it is not, right? Or it may neither periodic or in time, not in space, right? Therefore, all waves are disturbance, but not the vice versa. So we can conclude that all waves are disturbance, but not the vice versa. That is, all disturbance is not the wave. When it will be waves, then it has the characteristic, it must be periodic in space, it must be periodic in time, right? But disturbance can be either periodic in space or periodic in time, or may not periodic in space and time, right? So this is the disturbance. Now we consider the wave front. If we consider the wave, then you know from your class 12, that is 10 plus 2, you have learned a lot of things about wave, that is progressive wave and standing wave, and there are different parts, that is amplitude, phase, and from phase part you can extract its frequency, initial phase, time period, all those things you have already learned from the wave. Now we want to mention the wave front. So what is wave front? A wave front is defined as the locus of all such points which are in the same state of vibration, that is in the same phase. right? A wavefront is defined as the locus of all such points which are in the same state of vibration, that is in the same phase. If we consider a wave is exist in a medium, then if we draw or if we join all the particles of the medium which are in same phase, then it will give you the nature of the wavefront, right? So a wavefront is defined as the locus of all such points which are in the same state of vibration, that is in the same phase. And mathematically, we can represent it as kx equal to constant or kr equal to constant. The mathematical relation of wavefront, that is kx equal to constant or kr equal to constant. Kx equal to constant, it indicates a plane wave. That means a single dimension is there, kx, only x component. So we can say it is a plane wave or plane wavefront. And we consider kr equal to constant, that is, it indicates a three-dimensional, right? So that may be a spherical or cylindrical wavefront, right? In case of spherical or cylindrical wavefront, we can represent it as a kr equal to constant. When we consider the wave is considering or distributing in the radially direction, r indicates the radial direction. Now, so the equation of wavefront you need to remember, that is kx equal to constant or kr equal to constant. If it is plane wave, then kx equal to constant, or spherical or cylindrical, then we can mention it as kr equal to constant. Now, another thing that wave equation and its solution. Wave equation and its solution that you need to remember here. For example, if we consider a plane wave, so that plane wave can be represented by del square psi del x square, that is equal to 1 by v square del square psi del t square. And if you solve this wave equation, that can be solved by different technique is there in your mathematics. You have already learned or you will learn later on to solve the wave equation. So this wave equation for one such simple technique, that is the separation of variable. So if you apply this separation of variable technique and then you solve it and combine, then you will get the solution like this. That is psi I xt, that is equal to a sine k x plus minus vt, or a sine omega t plus minus kx. Right? So this can be considered as the solution of the wave equation. Now it indicates a plane wave, only x is involved. So this is the solution of plane wave, and you see the solution. It shows you the amplitude, which is a constant quantity. The amplitude of a plane wave is a constant quantity, and this is the phase part. This indicates the phase part. Okay? So the example of plane wave, that is light emerging out from a convex lens when a point source is placed at its focus. So if you put a point light source at the focus of a convex lens, then the wave coming out from the lens, that is the plane wave. Another example we can consider, that is the spherical wave. So the representation of spherical wave, that is the radial part. Here we are mentioning that the radial part, spherical wave, that is 1 by r del square del r square r psi. 1 by r del square del r square r psi, that is equal to 1 by v square del square psi del t square. 1 by v square del square psi del t square. And the corresponding solution will be psi rt, that is equal to a by r sine k r plus minus vt or a by r sine omega t plus minus kr. So here you see the amplitude of a spherical wave is no longer constant. Its amplitude varies with r, right? So for example, if you see first that light diverging from a point source. So if you put a point source of light, then light will diverge. And if we consider at any distance r from this source, then its intensity will changes. Its intensity will reduces as you move away from the point source. That means its amplitude is decreasing, which is proportional to 1 by r. So amplitude is a by r sine k r plus minus vt or a by r sine omega t plus minus k, right? So this is the solution of spherical wave equation. So it represents the spherical wave. Example is light emerging from or diverging from a point source. Another we can say that is cylindrical wave. The radial part of cylindrical wave, that is 1 by r del r, r del psi del r. That is equal to 1 by v square del square psi del v square, right? Cylindrical wave equation, that is 1 by r del r, r del psi del r. That is equal to 1 by v square del square psi del t square. Now, if you consider if you consider the solution of this equation, then we will get a psi rt, that is equal to a divided by root r sine k r plus minus vt or a by root r sine omega t plus minus kr. Now you see here amplitude is reducing, but the reducer's factor is 1 by root r, right? That is amplitude is proportional to 1 by root r, right? So like this way it is reducing its amplitude. So example of that, light emerging from a narrow slit. If light emerging from a narrow slit, then we can consider it is a cylindrical wave or cylindrical wave front.
29 also given 14 number
29
also number 1.
শুধু 15
বাকিগুলো থাকে
ঠিক আছে 29 অশোক এভিনিউ আচ্ছা কি করে যেতে হবে কিছু বলে কে সোজা গিয়ে যাওয়ার পর
সোজা গিয়ে কিছু না ওইখানে যে অশোক মনু বলে
হ্যাঁ হ্যাঁ
হ্যাঁ 29 যেটা সেটা চলে যাবে
29 ঠিক আছে
ওই এটা যাচ্ছ
হ্যাঁ
এই দিকে
ঢুকতে হবে
হ্যাঁ ঢুকে এবার শেষের দিকে বাড়ি
ঠিক আছে কালকে আমি বেরোবো সব খোঁজ করতে
জিজ্ঞেস করে নিবি
হ্যাঁ হ্যাঁ ঠিক আছে
সবাই জানে
এক্সকিউজ মি স্যার
ইয়েস
স্যার একটু মাইকটা অফ করে কথা বলবেন
ঠিক আছে ঠিক আছে Okay, now so this is cylindrical wave and its corresponding solution, and at the same time we have to mention the example also. That means if you consider a narrow slit, then it will produce your cylindrical wave front or wave, right? Now another thing we should remember, that is whether these waves what we are discussing, that is plane wave, spherical wave or cylindrical wave, this wave is already I have mentioned that it is periodic in space and time, right? It is periodic in space and time. So how we will establish this? To establish or to understand this, we consider that psi xt, that is equal to a sine kx plus minus vt. So if we consider, if we want to show you that it is periodic in space with periodicity lambda, right? If we consider that it is periodic in space, and for we assume that its periodicity is lambda in space, right? So we can represent that psi xt, that is equal to psi x plus lambda t, psi x plus lambda t. That means the particle which are vibrating at position x and the particle which are vibrating at position x plus lambda are in the same phase, right? So that means it looks like alike at these two positions. X and x plus lambda are in space, right? So if it will same, then we can write this expression, that is k sin k x plus lambda instead of x, that is x plus lambda plus minus vt, that is equal to sin k x plus minus vt plus twice pi, because you know its periodicity is twice pi. For particular sine wave, its periodicity is 2 pi. So this x plus lambda plus minus vt, then we can consider it as your original for x, that is x plus minus vt plus twice pi. So by comparing this, that is k lambda equal to twice pi. K lambda equal to twice pi, that is k equal to twice pi by lambda. This is the propagation vector. So this indicates the propagation vector, and with periodicity in space, that is lambda. Thus periodicity in space is lambda. Now if we consider it is periodic in time and periodicity is tau, that means within a interval t equal to 0 and t equal to tau, or t equal some value t and t plus tau, it represents the same things. Then in this situation also we can write that is sin kx plus minus vt plus tau, that is equal to sin kx plus minus vt plus twice pi, because twice pi is the periodicity of the wave. So under this condition, that is kv tau, that is kv tau, that is equal to twice pi, right? That is equal to twice pi. That is kv equal to twice pi by tau, that is 1 by tau, that indicates nu. So twice pi nu, that is equal to omega. So kv, that indicates the omega, that is the angular frequency, right? And this nu is the linear frequency, right? So kv equal to omega, that we can establish, and it will be periodic in space and time, right? So I will stop it here today before your Huygens principle, right? So next class I will introduce the Huygens principle, right?
Sir, please share the PDF in the file section.
Yes, sir.
Hello.
So please share the file on the PDF section.
Okay, okay. I will give it. You can find it out. Any question from this part?
No, sir.
Okay. Thank you all. So in next class we will continue from the next.
Thank you, sir.
Thank you, sir.
Thank you all.
Thank you, sir.
Yes.